So, arithmetic precision is about the precision of calculations or expressions. Like, for example, ints. Using ints, you have no floating point number. There is nothing after the decimal point. Whereas with floating point numbers like float and double, you have different amounts of precision. Double is double precision. So these are typically very important for certain considerations. So for example, if you're computing the interest rate of massive numbers and you're working for a bank, sure, this is going to be really important. On the other hand, if all you're doing is let's say points or something, you don't need if you're looking at scores out of 100, you don't need double precision for things like that. So it's very important to consider exactly what kind of types you need for a certain program. And there are some things to watch out for. In Java, actually, things personally I think are a lot safer. In C++, you may have expressions that might not evaluate as you may expect. So you want to be a little bit more careful with C++. Java, usually, for example, we saw that in Java, you may remember that if you say int x is equal to 3.1, that will automatically give you a compiler error. You won't get to run that program. You won't get to compile it because you cannot assign 3.1, which is by default a double, into an int. In C++, there is this automatic type conversion, which is sometimes handy, but then sometimes you may get unexpected results. This idea that the highest order operand determines the type of arithmetic precision performed is basically the same as promotion. We call this promotion in Java. And it's really the same idea here, but the book uses a slightly different notation. So watch out for, we'll look at some common pitfalls about using the use of higher order operands. Okay, so here's one, for example. If you divide 17 by 5, this evaluates to 3. And Java, if you're a Java programmer, this makes sense, perfect sense, right? This is what you would expect, because mainly this is a hardware limitation. You divide an int by an int. This goes into the hardware integer processing unit, which only takes ints, and the result is an int. So both operands are integers, and it goes into the integer floating point, the integer processing unit. I think I might have misspoken. There's an integer arithmetic logic unit that does the integer division in the hardware, and so you get an integer output. On the other hand, if you have 17.0 divided by 5, you know from Java that what happens is, in effect, the 5 is promoted to a double. Then these two operands can go into the floating point arithmetic logic unit or floating point unit in hardware, and that takes two doubles as operands and produces a double as an output, and so you get 3.4. So a lot of these things are very similar. This works the same in Java. This works the same in Java too. So if you're used to that, I think this won't be any surprise to you. Also, if you have two ints, like let's say int, the first variable, int var1 is 1, int var2 is 2, you divide the two of them and you perform an integer division. No surprise if you're a Java programmer that the result is a 0. So should be completely, these are all expected results. Okay. The one thing that you want to keep in mind, and Java programmers will be completely fine with this, when you have, let's say, a sequence of operators, in this case they're all divides, so there's 3 divides, Remember, for the rule from Java, and it's the same in C++, is that if you have operators of the same precedence level, in this case it's the same operator, so same precedence level, you go left to right. That is, you do this first, 1 divided by 2, which is equal to 0. Then you do a 0 divided by 3.0, which is equal to 0, and then, well, actually 0.0. So here, the thing to watch out for is that, well, this is an integer, and it's 0. And the expectation might be that since you have a double, you might expect that all of these things are promoted. No, that does not happen. Just the fact that one of them is a double does not make all of them a double. So you go left to right, it's 1 divided by 2, integer operation, you get a 0, you don't get 0.5 as some people might expect. I know if you're used to Java, you don't expect it, right? You expect this to be 0, and then 0 divided by 3 is 0, and then 0 divided by 4. Even though this whole thing is a double, it already became a 0 because the first divide was a 0. Okay, so I'm guessing most of you are okay with this. Just want to check. Let me know if this is unclear. Alright, so it's not necessarily sufficient to change just one operand. In this case, changing just the 3.0 to a double does not give you the result that you might expect. That is, changing the 3 to a 3.0, for example, does not make this a double. This 1 divided by 2 is still an int. Okay, so that's the pitfall. So you must keep in mind that all individual calculations will be performed during evaluation. So that is, in this case, you go left to right because these divides are all the same precedence level. Okay, next up, let's take a quick look at typecasting. If you're used to Java, we've done this with the usual way of using parentheses to do typecasting, and when we use C++, that's referred to as the C style typecasting. It's also available in C++ as it is in Java, but it's later on we will see that it's much better to do this, to say static cast, type of variable or the type that you want to convert to, and then in parentheses put in whatever variable, in this case int var. So for example, if you want to do an integer divide, if you have two integers that you want to divide but you want the result to be a double, for example, if you have two numbers then you want to get the average, you add them up. That might be fine as an int, but then when you do the division, you probably want to use a double division. So what this will do is convert this integer variable to a double so that now this is promoted to a double, and you do a double precision division so that the result is a double. So for example, let's say int var is 3, and int var 1 is 3, int var 2 is 2. If you want a double precision number, you want 1.5, but 3 divided by 2 with just integers would be 1. Okay, so doing the cast, in this case using static cast double, forces double precision division to take place with these two integer variables. So you've seen this in Java. In Java, the difference is that you use what is called in C++ the C style typecasting, which is to put in parentheses double. That is also available, but turns out in C++, whenever possible, do this static cast. Even when there's automatic promotion, you probably want to do that. So for example, you might want to put this static cast double on both sides of this divide. It's usually considered better, just because if everything is spelled out or explicit, that is, you explicitly convert this to a double, and then put the same thing here to explicitly convert this int var 2 to a double. Alright, so let's take a quick look at a program. and wrong file. Okay, so here is a short program using arithmetic expressions, and this part is actually quite different from Java in that if you have a double x, say 2.5, it doesn't matter what it is, it could be 2.0. If you try to do this in Java, you would get an error message because you're trying to squeeze essentially a 64-bit double precision value into a 32-bit int. You just cannot do that in Java. In C++, as we've seen before, no, you really shouldn't do this. If you ever do this, you want to explicitly cast it. So you want to say you should. Now this, let me just back up. This is allowed, so you can actually put a double into an int. C++, the compiler does some automatic type conversions, but it's not considered a good idea. And what would be better would be to do something like this. Okay, so even without the static cast, this program will work. It will give you x is 2.5 and y is 2. But it's much better to actually explicitly write out that you're casting. So let me compile this. Okay, and run this. Okay, so x, it prints out x is 2.5 and y is 2. That's what we expect. In Java, of course, we cannot do anything like this. We can use in parentheses int to typecast a double into an int. Okay, so next up, let's take a look at this. We say z is equal to y divided by 3. Y is an int, which is 2. 2 divided by 3, you might think will give you 0.66666, wherever. But it doesn't. So if you expect z to have 0.6, sadly mistaken, because y is an int, 3 is an int. You do an integer division, and that is an integer 0. Okay, so Java programmers, you probably expect this. Here is an illustration of, let's say you expect 1, because you have a 3.0, you expect the 1 divided by 2 to be a double precision number. No, it's not. And as a result, you get 0 for this whole thing, rather than some small, fractional number. Okay, so in this case, what I did was I said, press a key and enter to continue, and I'm going to put whatever the user types into this space. Doesn't matter what you type in. You can say whatever. Doesn't really matter in this case. And we move on to the rest of the program, and here what we're doing is we are sort of fixing this error. I guess you can think of it as an error. When you say double z is equal to result of an integer division, you want to cast one of them as a double. That's good enough. But if you want to be explicit about it, you would put it on both sides. It's considered good form. You can still use the old-fashioned or C-style casting, that is using the parentheses. And this is what we used in Java. And in Java, this is completely safe. We will see later on that the reason we use this static cast is that there are other kinds of casts that will become really important when we get to classes. It's not dealing with primitive data types like ints, floats, doubles, but when we deal with classes and pointers, what kind of cast you use is a whole bunch of them. One of them is dynamic, and there's a bunch of other ones. The kind of cast you use becomes critically important. In this case, not so important. It's just primitive data types.